everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on inverters problems and its solutions. First one is in that total 10 questions. In that first question is a single phase off-bridge inverter has a resistive load of 2 ohms and the supply voltage DC voltage is 24 volts. Calculate the RMS output voltage at fundamental frequency and output power and average and peak current. So now here the solution for this, and the given data is R equals to 2 ohms and supply voltage it converts from DC to AC. So now here DC voltage is 24 volts. Now here V01, 1 indicates the fundamental frequency. RMS output voltage formula is 2 into this VDC, 2 into VDC by root 2 into pi. So now this value equals VDC is 24 and this is root 2 and pi. So this one equals to 10.80. And next thing here, P0 equals to V0 square by R. So output power equals to P0 square. This V0 RMS square. So divided by R. So this is V0 equals to VDC by 2. So this output voltage equals to VDC by 2. And next 24 by 2. VDC is 24 by 2. And that value equals to 12. So now here what about this power? Output power equals to 12 square by 2 and that value equals to P0 equals to 72 watts. And what about the average current and peak current? Average current equals to VDC by 4R. So now VDC equals 24 and 4 into R value is 2. And what about the average value equals to 3. So this one 3 ampere. And next what about the peak value? Peak value equals to VDC by 2 into R. So now 24 into 2 into 2, that value equals to 6 amperes. So now this is the fundamental RMS output voltage V1 RMS, and this is the output power, and this is the average thyristor current, and next this is the average, peak current. Next, second question, a single phase bridge inverter has a resistive load of 2.4 and the DC input voltage is 48 volts. So VDC equals to 48 volts. This is the R value. Same as the previous one, same problem, same procedure. But here this is V01, V1 RMS, output RMS at fundamental frequency P0 and total harmonic distortion THD you need to calculate. So now here first one, same formula, 2 into VDC by root 2 into pi. So now here VDC is 48 and that value equals to 21.60. And next thing here, output power equals V0 square by R. V0 means here VDC by 2 and VDC means 48, and if you substitute in this 48 you will get the 24 is the output voltage. And next thing here, for V0, after getting V0, substitute in this. V0 is 24, substitute V0 square by R value, this is V0, and that output power equals to 240 volts, so 240 watts. And next here THD means here THD means under root 1 by GS square minus 1. G means here V01 RMS divided by V0 RMS. So V01 RMS means this one, root 2 VDC by pi, and V0 RMS is this one is VDC by 2, this one and this one. So root 2 VDC by pi, 2 by root 2 means root 2 VDC by pi. This is V0 RMS and this is V0 RMS is this one V01 fundamental and this one is the total VDC by 2. So in this this G equals 0.9. So now THD equals to 1 by G square minus 1 under root. So that 1 by 0.9 square minus 1 means 48.43. Next, third question. A single phase full bridge inverter has resistive load 10 ohms and input voltage of 100 volts. Calculate the average output voltage, RMS output voltage at fundamental frequency. Solution for this one, first one, V average equals VDC by 2, total average output average value, and that is 100 volts divided by 2, that means 50. This is 50, sorry. 50. And next, V naught RMS equals to VDC, and that value equals to 100. Next, here V1 RMS fundamental RMS output voltage equals to 4 by VDC by root 2 into pi. This is for a full bridge inverter. For off bridge inverter, 2 VDC. Now here this is 100 root 2. This is 4 into 100 divided by root 2 into pi. This value equals to 90.303 volts. And next, a single phase pulse width modulation full bridge inverter feeds RL load of 10 ohms and L value is 10 millihenries. If the source voltage is 120 ohms, calculate the total harmonic distortion THD distortion in the output voltage and in the load current. The width of each pulse is 120 degrees and output frequency is 50 Hz. So now here in this, so this is the output RMS voltage formula. If it is pulses, here VDC into under root 2D divided by pi. So 2D means pulse, here pulse width is here 120 degrees, this one. So width of each pulse 2D equals to 120 and D equals to 60. So now here the output RMS voltage is here. So that value equals to 97.38. And next, this is the output voltage here. This output voltage equation, if you dip from the DC to AC, in the AC output voltage, that equation is sigma into 135 till n and 4 Vs divided by n pi sin d sin omega nt. So now here in this, so first harmonic, so fundamental frequency component RMS value equals to 1 by root 2, 4 into Vs is 120 by pi sin d equals to 60, and this is RMS means 1 by root 2. So now this value equals to 93.5. So now what about the THD? THD means, so THD equals to 1 by G square minus 1 under root. So G equals to, so here G equals to 1 minus G square. G equals to, what is the formula? V01 RMS divided by fundamental RMS voltage divided by total voltage. So now here this one, if you simplify that, V total average output voltage square minus fundamental RMS output voltage divided by fundamental average output whole square. So now that if you substitute this 93, this one fundamental RMS output voltage and total RMS output voltage. So now THD value is 31.83. So now next case, here a single phase full bridge inverter has RMS value of fundamental component of output voltage with single pulse width modulation equals to 110 volts. So calculate the pulse width required and the RMS value of output voltage in case of DC source voltage is 220 volts. So now here solution for this one, this is the output voltage equation, AC output voltage. So now V0 equals to n equals to 1, 3 odd numbers till n 4 VDC by n pi sin d n sin n omega naught t and this RMS voltage, RMS output voltage equals to 2 root 2. This one divided by root 2 means 2 root 2 VDC by pi. If you substitute n equals to 1, fundamental, n equals to 1. So now this is 2 root 2 and VDC is 220 volts, and D value you need to calculate. This output voltage is 110 volts. So now D value equals to 33.36 and pulse width 2D equals to multiplied with 2, 67.42. Next thing here, a 3-phase bridge inverter delivers power to resistive load from 450 volts DC source, a star connected load 10 ohms per phase, and when inverter is operating in 180 degrees mode, calculate the load power in kilowatts. So now here there is a formula for line voltage. There are two voltages here in the 3-phase, line voltage and phase voltage. We know the line voltage and phase voltage relation in the 3-phase circuits. Same thing here. First that line voltage formula from the 180 degrees mode inverter, 3-phase bridge inverter. So Vs into under root 2 by 3, that is line voltage. So now here first calculate this line voltage. So now here line voltage equals to root 3 into phase voltage. So now VL equals to root 3 into V phase. V phase is equals to VL by root 3. So we know this formula, VL by root 3. So now VL by root 3 means this value equals Vs into root 2 by root 3. So now here 3, so that value equals to, this is the phase voltage. After getting phase voltage, so 212.13, line volt and phase current equals to that phase voltage divided by R, and after that 212 by 212.13 by 10, so this 10 ohms, and this value equals to 21.21, and power equals to 3 into I phase square into R, that value equals to 3 into 21.21 whole square into 10, so that value equals to 13.5 kilowatts. Next thing here, 7th question, a single phase half bridge inverter has a resistive load of 3 ohms, DC input voltage 50 volts, and calculate the RMS output voltage at fundamental frequency E1 and output power, average current and peak current of each thyristor. So now given data and solution. First here, so RMS output voltage at fundamental means that is output fundamental at fundamental frequency means that is V01 RMS, so output voltage, and 2 into VDC by root 2 into pi. Already we solved this type of problem in first and second problem. This VDC means that is 50, this is VDC. Now the simplified value is 22.5 volts, and after that P0 equals V0 square by R. So now here, so output power equals VDC by 2. Now 50 by 2 means that is 25. And next thing here, 25 square by RP, this one, this is 25. Substituting this, you will get the power value, and this R equals to 3. You will get the value is 208.3 watts. And next thing here, IT average. So now here output power is over average value of thyristor current, average value of thyristor current, VDC by 4R. So this one equals 50 into R, 4 into R, that value equals 4.17 amperes. Next, peak value of thyristor RMS current, so VDC by 2 into R, so that value equals to 50 into 3. So that equals to 50 by 2 into 3, that value equals to 8.34 amperes. Next, a single phase full bridge inverter has RLC load of 4 ohms, L equals to 35 millihenries and C equals to 155 microfarads. the DC input voltage of 230 volts and the output frequency is 50 Hz. Develop the expression for load current up to fifth harmonic. Also calculate the average RMS value of all the fundamental current components. So see the question first. This is the output voltage equation. V naught equals to sigma n equals to 1 3 5 until n 4 into Vs by n into pi sin n omega naught t. So now up to fifth harmonic. So now if you substitute 1 3 and 5, so here 1 3 and 5, this 4 Vs is same. Next here Vs equals to 230 volts and remaining is same. And now here this equation is, so omega t means here, so omega L, so 2 pi f value is 50, 2 pi f, so 2 into 3.14 into 50, so 100. So now here 314 is omega, 314 is omega, 314 is omega. So now here 1 into 3 into 5 into this 5 and this 3 and this 1, and next 1 by 3, 1 by 5, 1, and this one is 4 into 230 by pi means that is 292.85. Next here we need the current. So for the current for the current equals V by Z, always V by R. So now for that case you calculate the Z value. Z equals to R square under root R square plus n into omega L minus 1 by n into omega C. So now here 4 square R value is 4 and omega L and say omega. So omega L 2 pi f into, this is the L value, this one, and this 1 by 2 pi f C. This value is, this one is C and this is N and this is N. So now here angle, phase angle is also same, tan inverse omega n into omega L minus n 1 by n omega C by R. So 2 pi f into omega L into n and 1 by 2 pi f C into n by R. So now here same thing here, this value. So if it is this n equals to 1, substitute 1. If it n equals to 2, substitute 3, substitute 3. If n equals to 5, substitute 5. So now here same thing here, substitute 3, 5 and 1 here. So now phase angle is for 1, so that value is 67.25. and next if it is 3, that value is minus 81.3, and next if it is 5, this n value, that one. Same way here if it is 1, so that value is here 10.34. if it is 3, that value is 26.46. if it is 5, that value is 51.05. So now if the simplified equation is here 20 I naught current, load current up to fifth harmonic, so that is 28.31 sin 314 t, this is omega, plus this angle 67.25 plus this value is 3.68 sin 3 into 314 omega t minus 83 plus this value is 1.14 sin 5 into 314 t minus 85.5 degrees. So this is the developed expression for load current up to fifth harmonic. So now here, and also fundamental harmonic current means this one divided by root 2. So first one, this one, that value equals 20.02 amperes. So now here ninth question, in the single phase series inverter, the operating frequency is 5 kHz and the thyristor turn off time TQ equals to 10 microseconds. Circuit parameters R equals to 3 ohms, L equals 60 Hz and C equals to 7.5. and supply voltage is here 220 volts DC supply, and calculate the circuit turn off time and maximum possible operating frequency assuming a factor of safety factor is 1.5. So now here there are formulas related to this circuit turn off time equals to pi by omega and pi by omega r. Here what are the omega and omega c? Omega means 2 pi f. We know very well this one. F is given operating frequency, and omega r means under root 1 by LC minus r square by 4L square. So now this one is 1 by LC. This is a L and this one is a C. So now this is 60 into 10 power minus 6 and this is a 7.5 into 10 power minus 6, and 4 into R means this one, and next C means L means 60 into 10 power minus 6 whole square. So now the calculated value is 39.2 into 10 power 3. Now here TC equals to, we can directly pi, this is 2 pi f value is 5 into 5 kilohertz, this one 5 into 10 power, and pi by 39.9 into 10 power minus 3, that value equals to 21.46 microfarads. And next here another equation is this circuit turn off time and safety factor into pi by omega equal pi by omega minus pi by omega r. So now here this value equals to, so now here pi by omega means this is 2 pi 5 into 5 maximum. So now 10 into 10 power minus 6, that is this value 10 microseconds into safety factor is 1.5, and this one pi, and this is the omega r. So from this you can calculate the phi max, the f maximum, that value equals to 5345.5 hertz, means 5.3455 kilohertz. Next here, a single pulse width modulation full bridge inverter feeds RL load with R equals to 10 ohms and L equals to 10 millihenries, and source voltage VDC equals to 110 volts. Calculate the total harmonic distortion in the output voltage, and the pulse width equals to 2D equals to 120 degrees, and output frequency is 60 Hz. This problem is very simple. So now here we know very well this formula, Vrms equals to VDC by VDC into under root pulse width divided by pi. So pulse width is 120, 2 pi by pi 3, and this voltage is 110. This Vrms equals to, this is output RMS is 89.8. So now here we need the fundamental harmonic. So now THD means, what do you mean by THD? That equals 1 by G square minus 1. G means V01 RMS divided by V0 RMS. So now V0 RMS is over V01 RMS you need to calculate. So now that value equals to this one. In this if you substitute 1, so now here this is 1 and divided by root 2 means that is V01 RMS, 1 by root 2, 4 into this is Vs, and pi by 3. D means here 2D equals 120 and D equals 60, that means pi by 3. So that value equals to 85.7. So now THD means here, if you substitute this one in this, THD equals square root of Vrms, total harmonic, total RMS voltage square minus V fundamental RMS voltage square minus divided by fundamental RMS voltage square. So that value equals to 89.8, this one, and this one is this one. So now the total harmonic distortion is 31.83. So now I hope all these 10 problems are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.